Have you ever wondered, like, how do engineers know that a bridge that's, like, 100 years old is still safe? Like, how do they make sure that an airplane wing won't, fall apart in midair?
It's a question a lot of people probably don't think about, but it's obviously super important.
Totally. And the answer, my friend, lies in this super cool field called non-destructive testing.
Yeah, non-destructive testing specialists are the ones who get to answer those questions.
Right. They get to make sure things are safe without, like, actually breaking them open to look inside. That's got to be so cool. So today, we are diving deep, my friends, into the world of non-destructive testing.
What they do, the tech they use.
How to even get started in this field. It's going to be
It
fascinating.
really is fascinating work, and it's something that most people don't really know that much about.
Yeah, it flies under the radar, but it's essential.
Exactly. I mean, can you imagine being able to see inside an object, find any hidden cracks or weaknesses without having to cut it open or break it apart?
That's like straight out of a comic book.
Right. That's essentially what non-destructive testing specialists do every day. They're like detectives, but instead of solving crimes, they're preventing disasters.
Okay, I love the detective analogy. So they're out there inspecting bridges, buildings, pipelines, planes, like anything and everything.
Pretty much, because think about it, they're the ones who are ensuring that the things we rely on every day are safe and sound. I mean, it's a huge responsibility.
Absolutely massive. And the range of industries they work in, it's incredible.
Oh yeah, we're talking aerospace, manufacturing, oil and gas, construction, you name it.
If it needs to be inspected for safety and reliability, there's a non-destructive testing specialist on the case. Okay, so we've talked about what they do, but now I got to know, how do they do it? What's the tech like?
Well, they've got some seriously cool tools at their disposal. We're talking X-rays, ultrasound, infrared. Each one of these gives them a different way to look inside an object.
So wait, are you telling me they're using like the same ultrasound technology that doctors use to look at babies, but like on a bridge?
Well, it's similar technology, but yeah. And just like doctors can see bones and organs, industrial X-rays and ultrasound can reveal hidden flaws in things like metal welds, even concrete.
That's mind-blowing. And they use those sound waves to like pinpoint cracks that you couldn't even see with the naked eye, right?
You got it. It's all about analyzing how those waves travel through the object and then bounce back. Any little anomaly, any tiny crack, it'll show up.
Okay, and what about infrared? Because all I can picture is those ghost hunting shows.
Uh-huh. Yeah, those are always fun. But in non-destructive testing, infrared is used a little differently. Think like faulty wiring or energy leaks. See, infrared cameras are super sensitive to heat, so they can pick up on even the slightest temperature variations.
So if there's a hot spot, they'll know about it.
Exactly. And that can tell them a lot about what's going on inside an object. Could be an electrical fault, a leak in a pipe, even just bad insulation.
It's crazy how these technologies, which seem so futuristic, are actually playing such a critical role in our everyday safety. It really is amazing how this technology works. But I'm curious, what about the people behind the tech? Like, what does it take to actually become a non-destructive testing specialist?
Well, obviously you need to have a good understanding of the technology.
Right, like you can't just pick up an X-ray machine and suddenly become an expert.
Exactly. So a strong foundation in science and engineering is definitely helpful. But it's not just about knowing how to use the tools. You also have to be able to interpret the data.
So it's like being a detective and a scientist, kind of.
Exactly. You need that analytical mind to really understand what the data is telling you. You have to be able to look at an X-ray image, for example, and know what you're looking at, what's normal, and what could be a potential problem.
And then you have to communicate those findings to other people, right? Like the engineers who are actually going to fix the problem.
Absolutely. Communication is key in this field. You need to be able to explain complex technical information in a way that's clear and easy to understand, even for someone who doesn't have a technical background.
So it sounds like a pretty demanding job. What's the typical